This is an introduction to our second and last day of 6.2. We're going to talk more about dot products, but these are going to be applications of dot products again. So we've done dot products, we know the basics behind those. Now we're actually going to use them in some formulas, and one application of this is called a projection. So we are going to project one vector onto another. You'll see this picture here that involves making this vector sort of cast a shadow onto this main one down here. So think of, just imagine kind of that there's this light source directly above this vector. It's going to be shining directly down on this, and it's going to be casting a shadow down onto here. This is called the projection of u onto v. And the way we write that is the one that we're going onto is just a little symbol. So the projection of u onto v, that's going to be this vector right here. So that will just be this red vector right here. That's the projection of u onto v. Now v is the entire thing. V is this side all the way from here to here. This is v. But the projection is the red one. Now once we get that projection, then we also break it up into a couple of component vectors to make the triangle that you see right here. We also have a vector that's going up right there, and we call these two, well, since they're perpendicular, they're called orthogonal vectors. You'll see from time to time they'll ask you for the vector u as a sum of two orthogonal vectors, and they're referring to this one and this one. So we'll call this one u2, and then we'll call the other one u1. That just indicates the two that add up to get our original vector u. u1 is always the projection of u onto v. So we're going to think about this kind of setup as we look at our formula, because the formula, as the book gives it, is this. So this is our projection formula, and there's not a whole lot that you really need to know about what's behind this formula. It's just the fact that we're using a dot product in here, and we're going to be calculating the projections from this. So we'll be using this formula here in the next example. Just know that all this stuff will come into play. We'll be thinking about the picture that we started with right here whenever we're doing a projection, and we'll include pictures as we go along also.